what I have here is two beams, two I-beams, and they're supported on both ends. As you can see, they're 10 meters long. But one is vertical like this, and the other one is horizontal. So yeah, I mean, I'm just showing the supports here so that you see that they're fixed on both ends. But just to see things a bit better, I'm gonna remove the visualization of the supports. Okay, so you can see that one is vertical here and one is horizontal. And what we're gonna look into is how that affects the moment of areas and yeah, how that will affect the deflection later on. If you remember, the second moment of area is a measure of how much matter there is away from a particular axis. So in this case, we're going to look at the horizontal axis here, and what you can see is that, well, intuitively you see that there's more, because of the flanges here, there's more mass, there's more matter away from the horizontal axis in this configuration than in this one here, right? And this, well, we can confirm if I show the principal axis of my elements here. So the green vector is the first principal axis and the blue is the second principal axis. So if I look at the moment of area of the second principal axis here, so you see that it's 2.4 times 10 to the 8 millimeters to the fourth, and so that's the second along the second axis. And if I do it here, so you will see that on the first axis, which is the green one, you get 1.02. Okay, so it's like almost 2.5 times more when I'm in this configuration. And so you might be seeing what's coming. Now we're gonna put a weight on the middle of the beams here. So we're gonna put 5 tons, which is the weight of an elephant. And the point is to see which one deflects more. And well, intuitively, you know that this one is gonna deflect less than this one because of the position that it is in. And that's what this shows us here. So the red curve is the deflection of the center of this beam here. The blue one is this one. And you can see that here we have about 6 millimeters deflection against 13.5 millimeters. You don't see too much, but I can increase the scaling of my displacements by 20 times, for example. And now you can see here. So there you go. I mean, this is what your intuition tells you. That this beam here is going to deflect less than this one when you put like a vertical load on it. So the explanation is that the second moment of area along the horizontal axis here is larger for this beam, the one that's in vertical configuration than this one. And so that responds to your intuition. So it's pretty cool that you can actually see how the deflection happens and happens according to what you would expect to happen. So that was just a short video, short illustration of moment of areas. I hope you liked it, and as always, you can like and subscribe to the channel. See you around.